Here we go, boldly, well, I guess investigating where other people have gone is what we're doing.
Yes, we're safely here.
We're safely here. We call it Beyond the Sun. Harrison is here, and it's a segment where we take a look at what's going on out beyond our atmosphere. And water on Mars is on your mind.
Water on Mars is on my mind and many people's mind after some new data came back from the Curiosity Rover that's on the surface of Mars. This is sort of the SUV-sized rover that's been driving around on Mars since August 2013, I guess. It's been there a little over a year now.
Okay.
And its latest data from the base of Mount Sharp, that's a 5-kilometer high mountain there. You can see some pictures of it that we're seeing there. And it is revealing that the water that was on Mars in the past, of course, people have understood that there has been water on Mars in the past. It turns out, at least at this location, that the water that was there for an extended period of time. So not just, a couple hundred years or something like that, but perhaps tens of thousands to millions of years, if not longer than that.
How would they know that?
It has to do with how the sedimentary rocks built up and the layers of it at the base here of this mountain, because this mountain is something that they're finding out it was actually was built by sediments building up over millions of years. And so this is sort of one of those pieces of the puzzle in terms of whether or not Mars could have ever supported life. The Curiosity rover that's on Mars, it's not going to directly detect whether there was life there or not. It doesn't have the ability to do that, but it's working on figuring out if the conditions were ever right that life could have been there. And so it's finding different things in terms of what the temperature was, in terms of what the materials in the rocks were. And now this one is how long was the water there on Mars? And the results from this one indicate that it was there stable for an extended period of time.
So you could have water for a long, long time and still no life. Can you have life if there's no water?
As we understand life, it does require water in some form. It doesn't necessarily have to be a lot of it. It could be ice. It could be different things. But as we understand life, that we would recognize, yes, you need water.
But even we have creatures on the planet that live in volcanoes and things like that, but there's still a way for them to get moisture?
But there is moisture around. It's in the air. It can get it through the rocks. As we understand it, water of some sort, yes.
Okay.
In terms of the other question, could you have water and no life? Yes, you could, because water is one requirement for life as we understand it, but there are other requirements as well. And one of the issues that Mars faces particularly today is that it doesn't have a global magnetic field the way that Earth does. It protects us from the radiation of the sun. Mars today doesn't have that. In the past, scientists do believe that there was some sort of planetary field. There's also things in terms of how thick the atmosphere is. Does it protect you from radiation coming through from the sun? Because we have a nice thick atmosphere here, or thick enough that shields as it absorbs a lot of that UV light that would sterilize organic material. Like that happens on Mars today, but of course on Earth we're protected from that.
So where'd the water go? Because there isn't an atmosphere to hold it in. It has less of a gravity, does it not?
Yep.
Does all of that and the fact that eventually the water could just kind of drift away from the planet?
Yeah, there's an open question as to where it all went. There's an orbiter that actually just got to Mars not too long ago, the MAVEN spacecraft. We've talked about it before. And one of its main goals is to figure out what happened to Mars' atmosphere. And then that also helps to inform where the water went. Some of the water people think is probably still on Mars. It's beneath the surface, frozen in like a permafrost layer, something like that. And it's also certainly possible that some of it was lost out into space, just like it's suspected that a lot of Mars' atmosphere may have been as well.
Now, what about the opposite? Suppose a planet did not have water. Could it get water?
Yes, that is an excellent segue into the next topic, which is Rosetta, which is out around Comet 67P. And the idea has been going for a long time that on Earth, in its early days, it was too hot here. And so our water would have been boiled away, which means then the water that's here on Earth or any other planet, Mars, for example, may have gotten that water from objects such as comets, because comets are made of rocky, icy things.
How could comets have brought as much water as we have on this planet?
Well, when the solar system was young, there was a lot of things flying around it. It was a busy place. Earth was getting hit by comets constantly, large ones too. And in fact, we still are today, but they're thankfully quite a bit smaller for the most part.
Yeah.
Every day there's hundreds of liters of water being deposited into Earth's atmosphere from comets, things hitting the Earth. It happens all the time. In the past, it would have happened on a larger scale, except it turns out with this data that Rosetta is returning, it seems like the type of water that is on Comet 67P doesn't match the kind of water that's here on Earth. There's a ratio between hydrogen and deuterium. Deuterium is heavy water, essentially. The the nucleus of the atom has an extra neutron in it. So
Okay.
hydrogen is 1 electron, 1 proton, but if you get this heavy water, it's 1 proton, 1 neutron, and 1 electron. So the water is a little different, and you can measure the ratio between the sort of normal water and the heavy water, and the ratio in Earth's oceans is about 1 atom of heavy water for every 6,000 of normal. The ratio in this comet here, it turns out, is about 3 times higher than the ratio here on Earth. So that means that the water on Earth isn't coming from comets like that. And they've looked at other comets too. And so then that leaves, okay, if it's not coming from comets, where is it coming from? It turns out that the ratio of this hydrogen to deuterium in asteroids more closely matches what's in Earth's water. So then the idea is that, well, asteroids maybe are bringing the water here.
All right. So this is something that actually nobody really knows. It's just gathering more information all the time.
Yeah, we don't have all the answers, certainly.
All right. There is in December an important space anniversary, and we'll discuss that coming up straight ahead on Straight Talk. It's December, and here on Beyond the Sun, we remember in December, that's the month that is very important to moon travel.
Well, it was the last time, December 1972, 42 years ago, the last time that people were on the moon. It was the Apollo 17 mission. It launched early December. It was December, I'm going to get it right, December 7th, 1972, launched 4 days later. It got to the moon, landed for the very last time people touched down on the moon on December 11th. 1972, and this was the longest surface stay on the moon. Now, all the missions, the Apollo missions from Apollo 11 when it first landed, up to the last landing, Apollo 17, the surface stays were getting longer and longer. They were doing more and more science. They were venturing further out.
You don't mean the days on the moon. You mean the days that people stayed on the moon.
Yes, the duration of the surface stay was longer. Yes, that's right. They had the lunar rover for the last few, certainly including Apollo 17, and so they did quite a bit more science. And so they spent a total of 22 hours outside on the surface of the moon over the course of 3 days on the surface of the moon. They left the moon for the last time December 14th, 1972, and then splashed down December 19th, 1972, safely back here on Earth. 3 astronauts, I think the best named astronaut in certainly the history of anybody that's been on the moon, his name was Harrison Schmitt. He's, I don't know why I would think that he's the best named astronaut, but he was. And he was actually also the only scientist that's ever visited the moon. All the other ones were military people. He was actually a scientist. His commander, Gene Cernan, was also the very last person to set foot on the moon. So Harrison Schmitt and Gene Cernan were the last 2 people on the surface of the moon.
So why have we not gone back for all this time? There's certainly a lot of time, effort, and money being spent on space exploration.
Certainly a lot less, though, than was being spent in the 60s and early 70s. The big impetus at that point in time was to beat the Russians there.
Yes.
Once they did that, there wasn't really that backup, well, we need to figure out how the moon formed, or they started trying to do the science, and well, we're here, we may as well do it, but it really wasn't the driving force behind those missions in the first place. And so then once that political objective was satisfied, there wasn't really a compelling enough reason to keep spending the money that they were spending on it. And so now we've seen over the last many years, there's been this sort of slow, incremental build to getting back to having the capacity to mount, these sorts of journeys. But it takes time when you're spending, 0.5% of the American budget on it at NASA instead of, 3, 4, 5, 10% of your budget on it. It changes what you're able to do each year. They were doing launches to the moon every 6 months.
I don't think they're going back to 10%. That's not going to happen. Also now the gaze has turned from the moon to Mars.
Mars is certainly something that is now in the crosshairs. But again, it's a sort of incremental build towards there. The moon was something, we're going to do this before the end of the decade was the impetus. And of course they did. They got there in 1969. And the pledge was made in 1961. Now with Mars, what we're talking about is this sort of incrementalism to get there. The idea is sort of the mid-2030s is the goal to have humans around Mars, perhaps boots on the ground, perhaps orbiting, but certainly having people around Mars in sort of the next 15 years at this point, which 15, I guess 20 years to get to mid-2030s. I think that's sort of an exciting thing. Some of it is that the technology isn't quite there yet. I think if you wanted to put a rover on Mars, we can certainly do that reliably. We do that all the time. But to have people supported in a way that you could have confidence that they'd be okay to get there and back in terms of the radiation environment, in terms of supplies, in terms of power, in terms of being able to deal with the isolation. This is something that scientists are still working on.
Well, it's getting the technology there. I mean, clearly we've done that. That's not a complicated thing in terms of, gee, how could we do that? It's
Well,
already been done.
But there's a big difference between putting a 1-ton rover on the surface, landing a rover, and landing, say, a 10-ton capsule that would support people. It's an order of magnitude larger, and so that complexity does change the game.
But there's also the complexity of that length of a journey, too, for people to travel there, do something, and travel back, or not.
Well, or not, and that's sort of an interesting one. You're right in terms of length of journey. A robot, you just turn it off or leave it on. It doesn't care about the passage of time. People do, and so people need supplies. They need water. They need to exercise. They need all these sorts of things. They also need to not go crazy. So you have to figure out how to deal with that isolation. And then there's the getting back, which is the tricky part. There's one project called Mars One that proposes just to send people on a one-way journey. I think there's sort of certainly mixed feelings out there in the community about whether or not that's a good idea.
Well, there are people who would do it.
There are absolutely people who would do that.
All right, for you, is it Happy Holidays or Merry Christmas?
Merry Christmas, Jerry.
All right, that mini controversy comes up every year.